Welcome back to the channel, everybody. Today we're going to check out this some interesting details about the Lexus GX550. Now, I know this is a Lexus LX600, but it's being taken apart here, and we're going to see some interesting things. The first thing I want you to take notice of is this front cross member here. So, again, this is a Lexus a Lexus LX600 that we're looking at being taken apart for the Baja 600 rally race, but it's the same TNGA platform as your Lexus GX550. So in case you didn't know, Lexus GX550, Land Cruiser 300, Lexus LX600, it's all the same stuff. So all this applies to the Lexus GX550. So we're going to talk about some interesting stuff, the turbos, the engines, and some frame stuff. So look right here. You can see this, it's hard to see, but this black piece here where the mouse is, that's actually a front structural member that's new to the TNGA F platform. So the Lexus GX460, the current GX, doesn't have this. So this is a reinforced kind of top bar on the radiator support here. And as they take the bumper off here, you're going to kind of get a sneak peek of where it was at. So if you look here, you can see there's a bolt hole here and a bolt hole here. You can see they left the bolts in, and they took it out already. But there's a whole reinforcement bar that's kind of in here. So it's the old radiator support was flimsy, in my opinion. You know, it's weird. Honestly, I think it's one of the most sus, or as the kids say today, the most sus parts of the whole GX frame and body was the GX460, 4Runner, whatever you want to call it. It's all the same platform. Their old radiator support was some pretty thin gauge sheet metal. And so, as you can see here, they changed that. I mean, the GX460 sheet metal, 4Runner sheet metal, it was like 22 gauge up here, which is really thin for what this truck is, which is, you know, of course, a heavy-duty off-road truck. So I'm glad Toyota and Lexus addressed this on the GX550 by adding reinforcement here. So you can't see it in this photo, but there's a huge, thicker steel bar here to go across horizontally. And then down here on the vertical sections where it meets up, they're reinforced too. So bottom line is that's a stiffening member now, and it's way more supportive of everything. But it's going to be stronger, thicker, and it is again a stiffening component. So it's going to add to the refined feel of the vehicle as well as the longevity. Now he's taking off the radiator, just taking the whole thing apart here. So we're going to see some interesting things, and then we're going to talk. Let's check this out. We're going to talk about the turbos and the wastegate issues and all that sort of thing. Now, if you look here, now the first thing people do when they get their GX550, they're gonna take off the intake and put on a cold air intake. Look here. See where the mouse is? This is your intake right here. Believe it or not, you already have a cold air intake. In fact, you have two, because this V6 twin turbo engine has two intakes. So you're going to have a cold air intake here where I'm circling, and then all the way over here on the other fender, you're going to have the same intake. This V6, this turbo V6, has two intakes and two air boxes, which then lead to one central throttle body in the middle that then go to the V6 engine. So you do not have to put on some goofy aftermarket K&N filter that looks cool, because when you put in your the first thing people do is they cut all this out and they put a K&N air filter, you know, one of those cone filters, inside the engine bay. You're getting a Lexus. They already thought of that. Toyota has been doing this for years, and Honda has been doing it since at least the 80s, because I remember my old 88 CRX had the intake in the same position down by the wheel well on the outside of the body, outside of the engine bay, all the way down by the wheel well. So it's a true cold air intake. Now the previous GX 460 has the intake in the same spot. Just keep in mind you have two. You have one here, and then you have one, this GX550, and then you're going to have one over here. So you have two cold air intakes. If you put snorkels on these, which people might do in the aftermarket. You're going to look like an 18-wheeler because you're going to have 2 snorkels going up there. But you already have a cold air intake. Here we can see a little bit clearer where the paint isn't, is where that big supporting cross member goes. So again, that's going to stiffen things up. This whole radiator support that we're looking at here looks way beefier. In fact, on our GX550, we kind of tore up this radiator support because we put on a horrible aftermarket bumper that tore it up because it attached it here. But anyway, that's a tangent. Let's look at this crash bumper. Now, this is not the frame you're looking at here. This is not a frame member. Instead, that is the crash bar or crash bumper, whatever you want to call it. This is meant to take a lot of the shock of a crash. Now, on the GX460, this was like shiny aluminum. This almost looks composite, which would be cool if this was composite because it would make it even lighter. So I don't know for sure, but hopefully this is some lighter material because it looks, I can't see why they would paint the aluminum. They didn't paint them before. So maybe this might be, some sort of composite plastic to make it lighter than aluminum. Remember, this is not the front of the frame. The frame starts all the way back here where this body mount is that I'm circling. You don't want any heavy nonsense on the front because that's going to throw off that perfect centralized balance of this GX550. So don't be confused that this is the frame, but hopefully this is plastic and this will be a lot lighter. So that's an interesting note there. Now here's all the parts that they took off for weight savings. Again, this is a LX600 race car, but all this again applies to the GX550. I'm going to take a look at the frame here in a second. Here you can see the dual intakes. So you're going to have an intake on this side, intake on that side, and then they both meet up in the middle here and enter where the engine is. I know that it's not here in this image, but anyway, you get what I'm saying. You got 2 intakes, they meet in the middle. Now, incidentally, there's 2 versions of this engine. The car version of this twin-turbo V6 has 2 throttle bodies. So it's a little bit different. This one, the truck version only has 1 throttle body, but the car version you get 2. All right, let's look at the frame here. Now this is this beautiful Taylor welded frame. Look how shiny and it just looks so clean. On the current GX, this weld line here, if you will, this weld line is a lap weld. So where the mouse is, where these 2 pieces meet, that's a lap weld on the current model. On this model, this is not a lap weld, that's a butt weld, and it's welded with lasers. So if you look at this closely, you won't see all these, these weld all over the place with laps, and it'll look a lot smoother. But more importantly, it saves weight. So when you lap weld, you have to take a piece of metal and you go over, and that overlapping, so to speak, just adds a bunch of weight. And when you take the lap welds across the whole frame and add it up, it just makes a bunch of weight all over the vehicle. So they did this nice laser Taylor welded, which just butts it up with no lap, saves weight on both the frame and the body. So they did it both down here on the frame and up here on the body. So it's all over, and it makes it stronger, and you get more weight savings as well. Here's a look again, the bottom of the radiator support. Again, this crossbar is missing, but you can see it's a lot more beefy. These side areas here that I'm circling definitely look a lot more beefier. Now, I know I'm rambling a lot about the this frame and this body, especially the radiator support, but it will add a level of refinement that you'll feel. Again, here's this bumper. I don't know, it looks plastic to me. Now we're going to talk about the extra radiator here that I'm circling in a second. That's for the turbocharger. So a lot of people are going to have worries about this turbocharger, and then we're going to talk about this in a second. We're going to talk about the wastegate issues on this twin turbo V6 and how much you should worry or not worry. But it'll be interesting. There's another look at that body, and he's welding on, because again, this is a race car, he's welding on a support for the roll bar. All right, let's move on and talk about some technical stuff. And I'm not going to do this in any order, so I'm going to promise not to make it boring. So I'm going to make this as interesting as possible. Bear with me. I know this looks technical, but I'm just going to highlight some interesting things. All right, inside your new GX550, there is no traditional thermostat. Well, there is, but hold on a second. And this is for the cooling system. So you actually have a valve. I think it's a 4 or 5-way valve to control where the coolant goes. So no more do you have a thermostat that just opens or closes. You have this fancy motorized valve that can route coolant wherever it needs to go. It can block it to make the engine heat up quicker, or it can send it to the transmission to cool it off, or it can restrict it to the transmission. So you can see you have this very smart computer-controlled valve to send cooling everywhere. Now, the reason why I'm talking about cooling is because everybody worries that the new turbo engines aren't going to be reliable, and a lot of that mythology or worry, which is valid, don't get me wrong, it all comes down to heat. The turbo engines make more pressure, and they're not going to be as reliable, blah, 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 blah. You all know what we're talking about here. People worry about turbos because their minds go back to the 70s and 80s, where turbos were added as an afterthought. Check out this block here. This is the engine block of this V6 twin turbo, and it's beefy. It is not the same size block as the previous 4Runner V6. It is reinforced. It's thicker. It's beefier. It's stronger. The engineers made this from the ground up to handle being a turbocharged engine, and that's what I want to kind of press upon everybody here, is that the turbo was not an afterthought. And that's what people think, back in the day when they just manufacturer throwing a turbo after a few years to make more horsepower, to sell more cars, to claim that the horsepower went up, and they just added on as afterthought. And that's where all the bad stuff, the bad reputation of turbos came from. Anyway, let's talk about this. This here is the oil jets. So these jets will squirt oil underneath the pistons of the engine. So of course you got 6 pistons. Now in this engine, they have 2 squirters or oil jets per piston. To put this in context, your GX460 has 4 oil squirters with 2 openings for the V8 engine. So basically the V8 engine had 1 squirter per piston. This has 2 squirters per piston. This is all in the light of cooling. If none of that made sense, most cars have a single squirter, just one. Toyota knows this is turboed, and they're over-engineering by putting 2 oil squirters. As you can see here in the blue, these oil squirters are basically going to squirt oil on the top of the piston, or the bottom of the pistons, to cool them. So again, keeping turbo logic here, it's to cool the engine. So this thing is cooled with double oil squirters, 2 per piston. So that is pretty hardcore. That's pretty serious. And that lets me know that Toyota knows this is a turbocharged engine, and they're doing everything possible to keep this thing cool. Let's move on. Let's see what else they did to make it cool. Now in this diagram, they only show 1, but this is really 2. They're just showing a profile, but you get what I'm saying. There's 2 outputs here. The oil comes out here. But it's actually, the piston squirters are controlled by the ECU. So this is a solenoid valve. The oil from the normal oil pump comes in here, and then the ECU can command it to squirt under the pistons or not. Now, why would you block off the oil to the pistons when the engine heats up? In a cold morning, you don't want to overcool the bottom of the pistons, because you'll basically have fuel condensation and squirrely stuff happening. So it's they're overkilling it here by making this a very smart system. So your oil piston squirters have their own oil control valve, and they're dual. So there's 2 of them. All right, let's move on. Here's another shot real quick, and then we'll move on. We'll sail through this, and we'll start getting into more interesting stuff about the turbos. Here you can see the oil comes in, goes out. So you can see the path of the oil, and this can be turned on and off by the ECU. So this is a a very, very smartly designed system. Now here's the flow of the air, and this is what I was talking about. You have an air box here, and you have an air box here. So you have two air boxes on your twin turbo V6. They're cold air intakes, as I mentioned earlier. These air boxes are on the outside of your engine bay, down by the wheel well. You do not need a cold air intake. The air comes in here, it gets metered. So follow the mouse here. Okay, and then it gets compressed. Compressed just means pressurized. Okay, so it's just pressurized, and it goes in, goes through the intercooler here. That's what this crosshatch stuff is, and through your throttle body into your engine. And of course, it does the same exact thing on the other side. The issue that a lot of early Tundra buyers were having was the wastegate issue, which is down here. So this is the wastegate actuator, and that keeps the turbine from overpressurizing or overworking. So when the turbo is working too fast, so when these are the exhaust gas, so when the exhaust gas hits the turbine here and it's just going too fast for whatever reason, the wastegate opens, and which is right here. So the wastegate will open and allow the gases, instead of going straight to the turbine, it'll allow it to bypass through here, bypass the turbine, and go out the back. So the issue was with the actuator, not the turbo at all. The turbo was fine, the actuator. Additionally, it was some stupid electrical problem in this actuator that was traced to the American-only factory. You got to remember, these engines have been out since 2017 with these same actuators, and they've been around the world in the Land Cruiser 300. And they've been in the United States as the Lexus LS. So this engine has been around for a while and never had problems with this actuator until they opened up the Tundra plant. I forget where it's at, Kentucky, Texas, I don't know, America. So it was an assembly error essentially, and you got to realize that this actuator problem's been fixed. They didn't change the part, which indicates that it wasn't a part issue. It was an American assembly issue. I'm sure Toyota sent someone in there and basically told them to correct it or look for another job, that sort of thing, because there hasn't been any other issues. So don't blow it out of proportion that there's still this wastegate actuator problem. There's not. It's been solved. It was a production line issue. In America, there's been no more anecdotes reported online about the Tundra or the world market version of this engine. So don't sweat it. Now let's jump over here to the engine mounts real quick and talk about how, now I know you think, engine mounts are boring, but this is one of those refinement things. So your engine mounts in this V6 engine are actually semi-active. So at idle, when the vibrations are less, they're hydraulically filled with the diaphragm. So when the engine is shaking less, oil will flow freely around the engine mount hydraulic circuit. Basically, it will allow it to have softer dampening or absorption of the engine at idle. Then when you speed up and accelerate, this gray thing, this plate, closes down here, and you can see the oil passages block. And this firms up the engine mount. So your engine mounts have two modes. Idle mode over here, and then acceleration mode. So again, that's one of those small nerdy things, but it's all about refinement here, and that's what we're talking about. We're just randomly, casually going over random interesting stuff. All right, let's look at the wastegate in detail, or a little bit more detail here. So if we look here, you can kind of see what the wastegate is. So this should alleviate your fears, because people, if you don't understand something, it tends to hype up. Anyway, this is the wastegate actuator. All it is a stepper motor hooked up to this arm here. See this arm? The motor's in here, and then it tells this arm to push forward or pull back. Forward, back. That's it. and then it opens the wastegate, closes the wastegate, opens the wastegate, closes the wastegate. That's it. That was the issue. I don't know what happened at the factory, but they probably had a round of employees that didn't wire it correctly, or, put the wire loom where it shouldn't be. There was some error in production at the American factory that made this act squirrely and not open or close. Now, a lot of people think, well, that will ruin your engine, blah, 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 blah. No, it doesn't. This thing has a wastegate position sensor, so it knows that it's failing. So when these wastegates fail, it essentially goes into limp mode. It doesn't destroy the engine. It doesn't damage the engine. It will either fail in a fail-safe mode where it bypasses the turbo, or if it doesn't bypass the turbo, the ECU will adjust the fuel and the timing and whatever else so the engine doesn't get damaged. So there's no long-term catastrophic damage to this wastegate issue. It's a very simple device, and it's been solved. All right, let's talk about this. So getting back to the turbos and everybody worrying about the integrity of the turbocharged engine, we got to realize a couple neat things, and that is the turbochargers themselves have their own cooling system. So here's the main radiator. So this is the radiator that does the the normal engine cooling, and it also does your heater core to get heat, and it does your transmission cooling, etc. Blah blah. All right. Here you have a separate radiator for the turbos. So this is not your old school 80s, 90s turbo system where they simply tapped in to the main radiator and routed some cooling around the turbos as afterthought. This turbo system has its own dedicated cooling system. Radiator here, then it goes through to a water pump, an electric water pump. It has its own water pump. It's independent of the car's main water pump. Has its own routing. It goes around the turbos to cool them off. It's independent of your engine RPM, whatever else is going on with your loads and whatever else is going. It doesn't matter. It has its own dedicated cooling system. That's how well engineered this is. So it doesn't matter that you're going uphill, pulling or towing something, or you're going downhill, or you're revving the engine. It has its own independent cooling system. So it doesn't matter because this cooling system does not interface with the engine cooling system. So it's very well cooled. And the naysayers of the turbo system will always say heat, 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 heat. Toyota already knows that. So, again, this is just a casual going over of things, and there's no particular order of this. The main takeaway here is a few things, and but in the context of this video, and I know I'm rambling, we're just having a casual time here again. In the context of this video, don't worry about these wastegate issues. They're solved. There's no issue. Toyota will take care of it. The engine is not new. It's been around for a while, and the problem is isolated to the American market, blah, blah, blah. Second one is you got a smart routing here. So your cooling system is routed very intelligently. There is a thermostat in this system, incidentally. So this is the switching valve for your cooling system, and they keep a traditional thermostat somewhere in the system, say over here, as a backup. So if this thing fails, this electronic valve, you still have a backup old school thermostat. So again, very, very, very intelligently engineered. You got dual oil squirters. The weak point in your engine as far as turbocharging and heat is the piston surface. So the piston is just a very thin, hollow aluminum piece of metal. So, heat can't dissipate if it's thin and open to the air. The block can dissipate because it's a giant heat sink. So the weak point, the problem spot in a turbocharged engine is actually the tops of the pistons, which is why these oil squirters were invented. Most cars have one. This sucker has two per cylinder. So they're taking this cooling very seriously. So you got oil squirters, you got dual intakes, You got active, semi-active, engine mounts, and I think most of all is you've got a dedicated turbocharged cooling system. So your turbos themselves are kept cool, and your pistons are kept cool. So that's the takeaway. I know I'm rambling. Please forgive me. And if you're still here for some reason, please remember to hit like and subscribe. The point of this is to take away that anxiety. We have to condense the worries of turbos. What's the worry? The worry is the turbos will overheat, and then the other worry is the engine can't handle the stresses. Well, people say that. They don't realize the block is fine, the crank is fine, all that stuff is fine. It's thick metal that can dissipate heat. The issue is the pistons themselves, which are, very thin pieces of round metal. And that has double oil squares. So anyway, I rambled enough. If you found this video helpful, please remember to like and subscribe. Thank you, and have a great, great day.